I'm sure you've heard the news. Quantum physics is weird, but did you know your observation actually shapes reality? Let's unravel this mystery. In the quantum world, particles can be in many places at once. Until we look. That's called superposition. Back in 1801, Thomas Young conducted an experiment that would shake the foundations of physics. He fired light through two parallel slits onto a screen, expecting two bright lines. Instead, he got an interference pattern, proof that light behaves like a wave. But here's where it gets truly bizarre. Modern scientists repeated this experiment with individual electrons. Firing one electron at a time, they still got the interference pattern. Each electron was somehow going through both slits simultaneously, but the moment they placed a detector to see which slit the electron used, the interference pattern vanished. The electron started behaving like a particle, going through just one slit. The act of observation fundamentally changed the electron's behavior. This is the observer effect, and it challenges everything we thought we knew about reality. Erwin Schrödinger, troubled by these implications, proposed a thought experiment in 1935. Imagine a cat in a sealed box with a Geiger counter, a radioactive atom, and a poison mechanism. According to quantum mechanics, until we open the box, the cat exists in a superposition, simultaneously alive and dead. This isn't just theoretical. Quantum computers use superposition to process information in ways classical computers never could. While a classical bit is either 0 or 1, a quantum bit, or qubit, can be both simultaneously. Companies like IBM and Google are already harnessing this quantum weirdness for computational advantage. Einstein called it spooky action at a distance and refused to believe it was real. Quantum entanglement occurs when two particles become correlated in such a way that measuring one instantly affects the other. No matter how far apart they are, even across the entire universe, they remain connected. In 1964, physicist John Stuart Bell devised a way to test whether entanglement was real. Bell test experiments have consistently confirmed that entanglement is genuine. Particles really are instantaneously connected. The results violate what we call Bell inequalities, proving that no hidden variables can explain this phenomenon. China has already demonstrated quantum communication using entangled photons transmitted between satellites and ground stations. This technology promises unbreakable quantum encryption. Any attempt to intercept the message destroys the entanglement. Scientists envision a future quantum internet connecting quantum computers worldwide through entangled networks. But what exactly counts as an observation? Does it require a conscious observer? Modern experiments show that any interaction with a measuring device, conscious or not, causes wave function collapse. It's not consciousness, but decoherence, the particle's interaction with its environment, that destroys superposition. Physicist Hugh Everett proposed a radical solution. Maybe all possibilities actually happen. In the many worlds interpretation, every quantum measurement splits reality into parallel universes. In some universe, Schrödinger's cat lives. In another, it dies. Both realities are equally real. So can you touch a quantum particle? Let's think about what touch really means. When you touch anything, you're not actually making contact. It's the electromagnetic force between atoms that creates the sensation. The electron clouds around atoms repel each other, creating what we perceive as solid matter. At the quantum scale, particles are probability clouds, not solid objects with defined boundaries. When you touch something, you're interacting with quantum wave functions, the probability of finding particles in specific locations. Scientists use scanning tunneling microscopes to feel individual atoms, but even this isn't direct contact. The very act of trying to locate a quantum particle precisely enough to touch it fundamentally changes its properties. Heisenberg's uncertainty principle tells us we can't simultaneously know both the exact position and momentum of a particle. So in a sense, quantum particles exist beyond the realm of classical touch. They're more like mathematical possibilities than physical objects. Despite their strange nature, quantum affects power technologies you use every day. The transistors in your smartphone rely on quantum tunneling. Particles passing through barriers they classically shouldn't be able to cross. MRI machines use quantum spin properties of hydrogen atoms in your body to create detailed images. The future promises even more revolutionary applications. Quantum computers that could solve problems impossible for classical machines. They could simulate molecular interactions for drug discovery, optimize complex logistics, or break current encryption methods. Quantum sensors could detect gravitational waves with unprecedented precision, or navigate spacecraft without GPS. Quantum mechanics forces us to question the nature of reality itself. Is there an objective reality independent of observation, or does consciousness play a fundamental role in shaping what we call real? These questions have puzzled the greatest minds in physics for over a century. Today, researchers continue pushing the boundaries of quantum mechanics, exploring its limits and implications. From quantum biology to quantum consciousness theories, we're discovering quantum effects in unexpected places. Each discovery reveals new mysteries, reminding us how much we still don't understand about the quantum world. So, can you touch a quantum particle? The answer reveals the profound weirdness of our universe. At the quantum level, touch loses its classical meaning. Particles exist as possibilities until interaction collapses them into reality. We live in a universe where observation shapes reality, where particles can be in multiple places at once, and where distant objects remain mysteriously connected. Every time you observe the world around you, you're participating in the fundamental process that creates reality. You're not just a passive observer of the universe, you're an active participant in its quantum dance. The next time someone asks if you can touch a quantum particle, tell them, you're touching quantum reality every moment of your existence. The quantum world holds countless more mysteries waiting to be explored. From black holes to consciousness, from time travel to the multiverse, science continues to challenge everything we think we know. Follow Science Deeps for more mind-blowing science facts that will change how you see reality forever.